Well, thank everybody for coming, and I hope that you find this informative. My name is Gary McCullough. I'm Senior Director of Information Security for FINRA, and it's actually Information Security Engineering, which means I build stuff. I build a lot of controls, and we save the company a lot of money by building these controls ourselves. And we're going to talk about some of the things that we did for AWS, specifically in the areas of security and cost management, and I hope that you're impressed. Okay, FINRA, if you are a broker-dealer, you know exactly who we are. If you are not a broker-dealer, you might say, who is FINRA? And we are the Financial Industry Regulatory Authority. So there are about 430 broker-dealer firms that represent about 640,000 broker-dealers who are trading stocks today. And this may come as a complete surprise, but they all don't act ethically. And when they don't act ethically, it's our job to find them. And so that's half of our business, and the other half deals with big data. So we bring in every trade on the US stock market, and we run surveillance against that. We're looking to see if there's manipulations in the market. And you know, the volumes change, and that's something we had to deal with. So now, and you've heard this story before from tons of other customers, they have to deal with the volatility of volume, and that made the cloud really, really attractive to us. So that was our big impetus to go to the cloud. There we go. Okay, quickly, I give this presentation for AWS and non-AWS people, so we'll quickly go through this. You've probably dealt with this. We came from a place where it was system development life cycle, and we had the Henry Ford approach, right? You ordered a server, and then if you were a developer, you got all these calls from network people, DBAs, and all you wanted was to start writing code. And then came Agile and cloud development, so now you got your revenge on us. So you got what you wanted, but now what happens is that every single day you have developers in there, and they're making security decisions, they're making financial decisions, they're making capacity planning decisions, and that has to be managed because security and cost management doesn't automatically happen when you move to the cloud. You have to manage that. In fact, you may have to manage it more. So, and we actually dealt with this whenever the hacking, when hacking became more in vogue, is that we start saying we have to now train the developers to be able to do defensive coding and those kind of things. So sooner or later, we're going to have to deal with that on how we're going to do this for security, finance, and capacity planning. So are these new problems? No, they're the exact same problems. We solved them with the old Henry Ford method, but now it's just simply a new environment that we have to deal with. And these are some of the things you'll have to deal with. And I gave this 2 weeks ago, and then I have a little Yogi Berra quote there, and I went back to my hotel room and found that Yogi had passed, so that was very sad. Just thought I'd share that. Okay, AWS, so let's talk about security. Specifically, we'll talk about a little framework that we've built, and we'll do it based upon IAM. So you probably have that's your first foray. The first thing you ever see is you go into the console, they have IAM. IAM has best practices for you, and they give you that wonderful document, and they say, here, follow this. But they don't tell you how to follow it because that's really up to you. That's your responsibility into the cloud. And so there are a list of best practices, and we'll walk through those, and we'll show you how we solve those problems and how they can solve other problems in the cloud. Okay, so the easiest one has to do with lock away your AWS root account. All right? I mean, everybody knows you're supposed to do that. You don't want anybody logging in with that. All that stuff is carried through CloudTrail logs. And Splunk makes the collection of those really about a 2-minute job to do. So you still have to set it up in AWS, but once it is, then you want to collect it, and you want to go up to the SQS and then get the notification and go to the bucket. They take care of all that for you. So that made life really easy, and it also makes it workable. It's great to have CloudTrail logs, but sitting in a gzip file in an S3 bucket isn't really a workable solution. So Splunk brings that all in, and it fields all that data for you. So it's now searchable by fields, and now you can write queries against it. And that's exactly what we did. So here's an easy one over here. I want to know if anybody creates an access key for my root account. I would like to know that because we don't want any access keys for the root account. It's that simple. So I now implement that, and I can tell my auditor to leave me alone. And this little long one over here, I'm sending fields over to a ticketing system because I want to know if anybody logged into the root, to the console is root. So it's that simple. You just write a little query, and Splunk will do this for you. Is this all you can do at this level? No. If you want to implement MFA, that's in CloudTrail. You can easily create something for that. Splunk also enriches your data, so you can create whitelists and those kind of things. We want to know if anybody tried to log in. If you have any, we use federated services, but we still have some local accounts in there for different purposes. I want to know if anybody's tried to log into those from any network outside of FINRA's range. So is someone from China trying to log in with that account or whatever the case may be? Easy to do in Splunk, very easy to implement. Okay, rotate unnecessary credentials and get rid of unnecessary credentials. Again, nice to put in a best practice, but now you have to actually implement that. And for this, there's a lot of information you get from IAM, so we just have a little Boto code, and now it uploads it into Splunk. Splunk you want to put it in CSV, no problem. It reads that natively. If you want to take the JSON and shove it up there, it's okay. Splunk understands JSON. So it makes this really, really easy to be able to get this data in there. Secondly, let me get a little drink here because I'm getting dry. The other thing is that the IAM will tell you when the ID was created, and it'll tell you the last time it's used. So if you have time-based rules or regulations of when you want these keys to be rotated, easily implement it in Splunk. The more trickier thing is that when you have these, so we use a lot of ticket systems so that we want temporary, but occasionally we need to have hard-coded keys. And the idea is what happens when somebody leaves the company who knows that key, and what if they left for cause? So that's a real problem, right? So you need to be able to deal with that. Well, we actually assign those service accounts to an Active Directory group, and now we can pull that easily into Splunk, and I also get notification if anybody's ever left that Active Directory group. If they left it, I know it's time to rotate those keys so they don't go out into the parking lot and create havoc for me. Just a little bit of Python code for people who don't know. It's just simple to implement. That's not ours, but it's just to let you know that that whole little Boto Python box is really, really simple to implement. Okay, now one of the other ones that's a little bit more interesting is grant least privilege. So it's really, really easy for our good friends at AWS to say grant least privilege. And I went to the State of the Union for Security, and they said, they basically said the same thing. But how do you then, and your auditors will go pull these same documents and they'll come, how are you actually ensuring that you're granting least privileges? This is a little bit more difficult to do because it actually deals with cultural changes in your company. So the way we've solved that is we actually have a group of people, and we meet every week. It consists of security, operations, and development, and we've developed these roles because we're using federated services, so everybody comes on as a role. And we really went through all of the different APIs, and we decided which ones they're allowed to run and which ones they're not allowed to run. We put that into a CSV, to a version control system. You do what you want, and now we can actually pull data from IAM. And we pull that data from IAM, and we read it against the version control in Splunk, and now I know whether I'm compliant or not. So it's easy to come up and say, this is the rule, this is the set of APIs that you're allowed to run, but it's more difficult to say, is that really the way it's implemented in the cloud? And what's really great about this is what happens when your operational folks go in to make changes to those policies? Well, you can now leverage the CloudTrail logs. So CloudTrail will come up and let us know if any policy has changed that might change our security posture. And if it does, it will immediately rerun compliance on that and let us know. So did somebody put a wild card in the wrong space and then open up a ton of APIs? We know about it. So, and then you can also get really great reports from Splunk that if I want to come up and do remediation, I can now get a listing of exactly what needs to be changed. So I haven't found any third-party app that's able to do it at this level. So this was a big win for us. And then dashboarding. So Splunk has visualizations. Here it is for compliance. These things, the efficiency with which you can build these things literally take half hour to an hour. And we can just sit here, and I put a few of them here. Come on. And you can pump through, and now you can build these based upon that data for however you want. But is that all that you can do? Is it just IAM best practices? No. So I put a few other categories in which we do the same kind of compliance. And the great thing about this is the little bit of effort and time that it takes to do this is that you're not married into it. If you end up building something really arduous, then it's hard to get out. If your barrier to entry is really big, so is your barrier to exit. But it's always going to get supplanted through new AWS features. I mean, I don't know about you, but I was overwhelmed by how many new services came over the 2 keynotes. And they're going to supplant how you, or integrate with this on how you do that. So configs is a great example where we dealt with inventory management, but now Splunk will pull in the configs because AWS has that, and I now have a complete EC2 inventory at any point in time. So don't get too married into one method. Okay, so cost management. So, small story. There's a fox, and this fox is walking along, and he's hungry, and he comes across a vineyard, and he looks up and he sees these big, fat, juicy grapes, and he tries to jump up and get them, and he can't. And then he tries to crawl up, but he still can't get it, so he musters everything up, he jumps up, bites air, falls down, looks back at the grapes and said, they weren't ripe. Who wants to eat sour grapes anyway? So that little fable was told over 5,000 years ago by Aesop. And sometimes that's how things happen in the cloud, where you come up and you think that you're going to come up and get cost management, or that these things were going to be cheaper automatically when you come into the cloud. And the fox really has 3 different ways to view things. Either he can get the grapes, or he can admit defeat, that he doesn't have the skill to get the grapes, or he will rationalize it, the sour grapes theorem. I think they call it cognitive dissonance in parlance, but the point of the story is you'll hear people say, well, we didn't really go in the cloud for the cost savings, it was more for the agility. And those are the people that maybe aren't really doing cost management. It's really hard to do cost management. It's not easy. And if you want to be able to get the savings that you want from the cloud, you're going to have to work at it. So let's talk about project management. That's the portion I'm going to discuss right now. So we have right now what happens whenever when we do cost management and I have to deal with it. It's all backloaded, right? So you got your project, it got approved. You've already know what your hardware costs are, and that's all backloaded. And now I'm just managing labor costs. But in the new world, the other thing is that I have quarterly reviews. So somebody from finance will come and see me on a quarterly basis. And it's all pretty esoteric, and everything goes good, and we're usually on budget. But now I have tons of developers pointing and clicking, and they're going against my budget. So how do I manage that? You know, that's a problem. So I remember on the keynote they said, hey, this is great. Developers can now start up 1,000 servers. And I thought, no, don't give them that idea, because somebody has to pay for that. We're a nonprofit. You know, we're not an R&D shop. I can't just have people creating 10, 20,000 servers, because somebody has to pay for that. So what can I do? I can give them the billing report. A couple months ago, our billing report was 10 million lines. So I can put that on your desk, and you can go figure it out, and I'll see it. What do project managers need to know? What do they need to focus? Am I above or below my budget? Where are my costs going? And who's spending them? That's really what you want to know on a day-to-day basis. And manual compilation of these reports isn't just really a possible solution for that when you're dealing with this size. So what we said was, let's try to use Splunk, because Splunk can really pull in data, and it can variably do that. It has a great way to analyze that data, and it has great visualization ability. One of the things, so Splunk does have an app that will pull billing records for you, but we wanted the detailed billing report, and we wanted to get it more often. So we wrote our own back-end process to pull that in. Piece of cake. Then we had to do data enrichment. So project codes, I have to make sure that they're valid. Project forecasts, I have to know exactly what your budget is before I'm actually able to come to you and tell you whether you're above or below it. And billing adjustments. So if you deal with reserved instances, what you find out is on your AWS app is the person who actually used those resources doesn't actually get credit for them. So if you have two similar instance class, AWS doesn't care. They just know that you bought the reserved instance for that instance class. If that goes to project A, but project B was the one that actually purchased those, if you actually show that to the project managers, they're not going to be happy. So we needed to be able to adjust that. And our SME, our subject matter expert for billing, helped us with that. So that's what it looks like if you're left-brained, if you don't like the right brain stuff. So our app looks just like this. And it may look like a lot of things you see down in the expo, because I think it looks a whole lot like that. And we built this by ourselves. And a couple of data points. How long did it take to build this? So this was a skunkwork project. I built the back end. Siddhartha, who's going to talk next, built the front end. And Brink Trammell was our SME. And we did it part-time, and within a week we had it out to a set of pilot users, and after another week we put it out to general distribution. So let's take a little closer look. Okay, so if you look at the panels over here, what you'll see up in the upper left is your daily costs, and it is a stacked bar, and it's showing me what my AWS services are that I'm spending. And do you see that blue line? That's the budget. So if I look over to the right, it's the exact same thing, only it's by system development lifecycle rather than services. If I look down below it, those are the cumulative totals for that. So that was, and again, if you are right-brained, then there are the exact numbers. So the big question is did we have impact? I'll go back to here. We actually rolled this out right around mid-month of this month that we're showing. Look if you can tell if there's any change in behavior from the left side to the right. They were never below budget. But if I'm now able to, as a project manager, look at this and say, I can see exactly where my costs are going. And I can see which environments there are. And I can go look at CloudTrail and I can see who's actually spending these dollars. I can now make some informed decisions, and I can know which derriere needs a little kick because you're spending too much of my money. Because if you wait 3 months, you're going to have a very unpleasant discussion with your boss on why you overspent. And you can see the ones that go way down over there. Those are the weekends. All of a sudden, it changes behavior to say, hey, if I'm in development and I'm going home for the weekend and nobody's going to use that service, at least turn the things down because I don't have to pay for them. And it can have a really big effect. Oh, I'm sorry, wrong way. Okay, so did we have impact? Yep, so it changed behavior, came best practices to do some of these things, dormant EC2s and the associated EBS volumes. You'll see this in many different places. It also we were able to identify which AWS spending is the highest, so you know which one to attack. I mean, if it doesn't make any sense if you're actually going against the or you're trying to address the wrong problem. So I know exactly which services I need to do and where I need to change behavior. And I also can focus on which projects are most over budget. And the cultural change comes, and this was really, really big, and actually Tigran was here. I wanted to give him his team really, they get together, and once a week they walk through those graphs. And you don't want to be the manager that's sitting there way above the blue line, because it's going to be, sometimes a good old-fashioned witch burning is good for morale, but it's actually positive, right? Because other people are now coming in, they're telling you what their best practices are, and you can now make changes, but you have to make that part of the corporate culture. And so our first full month, I'm not allowed to share numbers with you, but the number of billing lines went down 13.5%. And when I made this slide, we didn't have it. It's the second full month that we implemented, we're down 20%. So, and I can tell you absolutely it resulted in lower costs. I have one project that was way over budget. It had never been below budget. This month was the first time they actually are below budget. If you actually give people a goal to reach towards, they'll do it. And this little app that we built in a week is able to do that. And we can actually change our forecast projections. So now we put the bar, and if you get below it, now we have to lower the bar. So that's always the case. Okay, so futures, they'd like shorter cycles, but I'm kind of at AWS's disposal for that. They only this is the resource with tags billing report, so they only update it so often. Back tagging, so since we decided to process that file, what happens if I build an EC2 on the 1st of the month, and then on the 15th of the month, I get notification that, hey, you didn't put a project code on it. AWS is not going to go back and re-tag your stuff. But since we process that data, we're able to go back and do that so that we can actually get the billing into the correct place. We're working on free rider services on how to build that, right? Things that aren't taggable in AWS, so that we can now put those in a separate cost center, and we can try to figure out how we can reduce those. And they want better drill downs. And to that end, we're going to talk. So now that you've done project management, what if you're still above budget? Is that the only place where you can do cost savings? So no, the answer is no, but you're going to have to dig a little deeper. But if you do, there's gold in them dark hills, because there's a lot of information that you can pull in. And we have a specific use case that we think that FINRA solved for software as a service in EMR. And Siddhartha is going to come up and show you exactly how we do cost savings in EMR.
All right. So FINRA spends millions of dollars every year on AWS, but and there are a lot of products and services which FINRA uses, and EMR is actually the most important one which we use, because we process a lot of data. So that's our main work, to do pattern recognition, things like those. So we just take large chunks of data and we keep processing them each and every single day. To give you an estimate, we run over 7,000 clusters, so you can understand the scale of processing which we do in EMR. And since we do it in such a large scale, we need to know how do we manage it, right? We need to gain the transparency into EMR, because it's basically a black box. There are other services which AWS provides it, but is that the only way to do it? So we wanted to look at different ways on how we can better that, or how we can gain more transparency into EMR. All right, so what are some of the challenges which we have in it? Product as a service and infrastructure as a service are not the same, right? You have very less flexibility and very less visibility into product as a service offering. And one of the challenges in that is instance fingerprinting too. In your regular environment, for an application, let's just say it's called ABC, and you have a web server, how do you define the host name standard as? Host is ABC and then web, something like that. But in EMR, what would you classify IP-10.1.1.1 as? You don't know which cluster it belongs to. You don't know what its role is. There's no context to that particular instance as is. So that's something which we were trying to solve. And there are 3 different components under that. And the first is how do we identify it, and then what are all the roles for that particular instance, and then what are all the user-defined tags around that particular instance. So that's something which we were trying to identify. Next is data retention. Now, AWS has a service called CloudWatch, and they provide you all these metrics for almost about 14 days. But what if you want to run a cluster, or you want to look at data of a pattern which you have run last month? Since we run so many clusters, there's always the same particular pattern job which we keep running multiple times, right? So how do I go back and look at it after a month? You can't. So that's something which we wanted to solve. Splunk gives you an ability to keep the data as long as your retention requirements are, your business requirements are. So we keep it for 1 year. So you can always go back for 1 year and look at how your particular cluster was performing at that point of time. Collection delay. AWS takes about 15 minutes to send data from your EMR cluster into an S3 location from where your developers can download it and then look at it. But then what if we wanted to solve that and to get the data more in real-time fashion, but not wait for 15 minutes for each and every single log file to look at. So that's something that we were trying to solve in the collection delay. We collect it almost near real time, probably less than 1/10 of a second. So I think that's the closest you can get. So to do all that stuff, what we did was we actually bootstrapped Splunk agent into the EMR itself. So it basically now becomes a normal EC2 instance. You're just running your inputs and things like those automatically. So how do we do it? So you have a small image there, you have an S3 location there, you have an EMR, and then the components under that. So we have a batch shell execute script, and that's a script which actually stays in all of our S3 accounts. So we have 3 different accounts. You can have more too, like QA, dev, prod, things like those. So whenever a cluster comes up, now this becomes a bootstrap action. Just give the S3 location and just say, okay, the BSS script will do all the work of installation and all that stuff. But in the BSS script, there are 3 different components under that. First one is a Splunk full-blown RPM. And then we have a deployment client.conf file. It's just a config file which tells it where its deployment server is to pull all the packages for it. And then there are some discovery scripts. We'll talk about what discovery scripts are and what we do with that in detail in a few next slides. You can install it on master alone. You can install it on all of them. It depends on what your requirements are, what your application requirements are. And few people want it just on master, few want it on every single place. It depends on that. So when we actually first came up with this idea, we thought AWS would really, and they'll say, no, you guys are trying to get into our area. So, but they were really supportive of the method, and they helped us out in figuring out all the config files, and then where is all the data actually stored, and how do you monitor that? So it was really good of them to help us out. So now coming back to the instance fingerprinting, this is also the very first part of the discovery steps on how do we identify them and things like this. So the first thing which we need to do is to find a unique ID for each and every single node. And this is how we do it. AWS has a metadata service, and it's at 169.254, 169.254. That must be the most coolest IP which they would have come up with. It's really easy to remember. It's just a curl command to that particular IP service, and that's it. You get your instance ID and IP address. Now, those 2 are the most uniquely identified by each instance, so we pick that. And then we also grab some of the user-defined tags by using the regular API commands. We use EC2 describe tags command, and we gather AGS tags. That's basically a FINRA standard way of saying what your application name is. It's basically application goal source tag. So that way we define, okay, this particular cluster, this particular instance belongs to this particular application. And then we have to determine the SDLC. Everyone seems to be really interested in finding out what the environment is. So that's one thing which we're doing there. Come on. Okay. So the next thing, probably the most important thing, is actually the cluster ID. Now, under EMR cluster, you have all these hundreds of nodes, cores, chars, and all things, right? Now, how do you say that all of these, when you look at those individual instances, how do you say these belong to one particular cluster? Now, that's one thing which we're trying to solve there. Each and every single instance, we go and look for what its cluster ID is. We extract that information. Now we use that to act as a gluing factor for all those instances to be able to join them together and say, okay, all of these instances belong to just this particular cluster. And then we also use the same jobflow.json file to get even the role of what each and every single node is. Now we have all this information. We collected these tags. We have unique IDs and things like those. Now we got to let Splunk know about that information. And now the second part of the discovery script is to be able to take all that information or knowledge which we are extracting and then add it into inputs.conf, which is basically a config file to say what this particular instance is. And this is, come on. And this is how it looks like. It looks a bit messy, but yeah, this is what you got. All the underscore meta information is basically tags. You're adding tags to that particular instance, saying, okay, this, and that's a host name standard. Now, which we have created for that particular node. What this does is each and every single data or every single event which comes from that particular node will be classified with these tags. So it's really easy for you to identify which core or which master or which task this particular instance belongs to. Now, all you need to do is just remember your cluster ID. You don't need to worry about the IPs, nothing. You just do host star cluster ID star. That's it. You'll see a whole list of all the instances along which belong to that particular cluster and the full aspect of it, performance data and all that stuff. Now we are doing all of this, right? Now what do we do with it? We built something called a cluster analyzer, which basically takes all of this data and you can pick a cluster there, and then you look at those cluster specific information. What's the name of the cluster? What's the start time of the cluster? What's the end time of the cluster? And how many hours did AWS bill you for that particular cluster? Now the second part actually has two different components. One, for the first thing, deals with CloudTrail data to give you information of who started it, the number of instances, type of instances, what's your bid pricing, things like those. And then the second and third panels are completely from billing. Now, the major issue I think with all the offerings which are available outside a marketplace is how do you calculate the overall cost of a EMR cluster? Because they can tell you cost on an instance basis, but how do you say that this is the cost of my full cluster? Because AWS, when they give you the billing data, they don't say that this particular instance belongs to, this particular instance for EC2 record belongs to this particular cluster. Now that's what all the work which we did till now solves that. Because now you have a full list of all the instance IDs for each cluster. Now you just correlate it with your billing data and say, okay, give me the pricing for all these instance IDs because all of these belong to this particular cluster. And that's it, you sum them up, you get this. It takes only about 10 seconds once you pick your cluster, and it'll give you the overall cost of what AWS really billed you for that particular cluster. And the third panel will give you item-wise description of what the cost is, so you know where you are spending your most money in. Is it input outputs, or is it IOs, or is it a data transfers, things like those. Now the next part is just hourly breakdown of your cost. But then the next part comes in. Okay, now I know what my overall billing for the cluster is, but how do I know that my cluster is actually working really well? How do I know that my provisioning is really done well? So that's what we look at here. So CloudWatch provides you metrics on a 15-minute average. What we wanted to do is to be able to get data in more real time or in a more granular fashion. So with the agent already installed there, the biggest thing what we were able to do was to get the data minute by minute, rather than waiting on a 15-minute and then get an average of the full 15-minute. So now we get the full view of CPU utilization, memory, and HDFS utilization for that particular cluster. So now whenever a developer is done with the cluster, he can always just come back here and just pick his cluster and see what the cost was, and then get an idea of how his utilization is. Now that gives him an idea on how to provision it better the next time, because hey, do I really need this much of nodes? So that's what we were trying to answer from this. So the last part actually deals with all the jobs which are running in EMR, and we take all those jobs, and then what we try to do was to take all of them and overlay it upon the performance data. So whenever you see a spike in CPU, you can just look down and see, okay, what was the job ID which was running there? Just click on the job ID, and then it's another drill down, which will take you to all the job-specific logs for that particular job ID. So you can see, okay, what was the job actually doing that caused a spike in my instance. Now, all of this work was to do savings, right? So now let's go into the first part of it. Provisioning savings. We look at we're taking an example of a cluster with 40 cores and tasks and a master, and with a configuration of M1X large instance. And in this scenario, the configuration we have is 15 gigs of memory at 35 cents per hour. But if you look at our memory chart there, it's only pegged at 40. We are never even using more than 50% of it. Do we really need an M1X large instance with 15 gigs of memory? We could have done with C3X large instance, which is half of the memory, but then it'll give you more compute cycles, but at the same time at a cheaper price. Now that, if you would have gone with that configuration, that would have pushed our memory to almost being utilized at around 70 to 80%. Now that's better when you look at it, when your managers want to look at how your provisioning strategy is. And by moving it into a different instance type is also giving you a potential 23% savings in your EMR cost for that particular cluster. Now the next part deals with a resizing structure. Now AWS gives you the ability to resize your clusters, right? Now we are picking that concept and trying to say, okay, now I've started this cluster, it's running for 4 hours. Now how do I determine what my strategy is for that? Because once you run it, and you plan to run that particular pattern job 1,000 times or 100 times, it's better you determine the strategy in the very first time rather than you run it 95 times and then your boss comes and says, okay, why did you spend that much amount of money? Then you go and look at your strategy and then run it perfectly fine for the next 5 times. So that's what we're trying to do. If you see there, our utilization is not really that high. It's only for the first 2 hours it's really that high. But after 2 hours, it's nothing. So we could resize the cluster basically after the initial 2-hour period. So let's look at the analysis. So in the original scenario where all the 40 nodes are running for the full 4-hour period, it's a simple cost formula, price per instance multiplied by number of instances running, and then the number of hours it was running for. It just cost us $56. But when you do the resizing strategy there, you really need all the 40 instances up and running the very first time because it's pegged at 100 most of the time. But in the second hour, your utilization is at 70%. You could bring it down to 35 instances. But whereas in your second and third, and in your third and fourth hour, you're not even crossing more than 30%. Do you really need all the 40 instances to be up and running for the next 2 hours? You don't. Now, when you bring it down to 20, that's your cost is going to be. It's going to cost you $40, and the savings when compared to the original scenario is 28%. Okay. Now, when you combine both the provisioning and resizing analysis, your original cost is $56, but when you combine it with both the analysis done, which is you're using the proper instance type at a cheaper price at 27 cents, the price is going to come down to $31. Now you're doing this particular job in 55% of the original cost. Now that might seem really less, right? Because it's only $25. And what can you buy with 25? Since we're in AWS, we need to talk only about AWS. So there are really few things which you can get from it. But what if this cluster is being run 5 times a day? And when it's run every single business day in a week, and when you run it in every single week in a year. Now that's just one cluster. Imagine the number of clusters which we run, and look at the amount of analysis which you need to do to bring your costs down, and look at the impact which it can generate. Now it's all small pennies, but when you have thousands and thousands of servers lying around which are running for multiple hours, it'll really soon turn into hundreds of thousands of dollars which you need to bring it back. And we are doing this without affecting any performance. It's just better provisioning strategy. Now we did all this not just to look at performance and cost, right? You can also look at some more Hadoop-oriented or more EMR process-oriented data. We collect something called job history data from the EMR systems itself, And then we built a small report. This was almost a month-old report. We have added a lot more components into that now. But what it basically looks at is how is my EMR as a service running? How is my map and reduce working? What are the number of slots or number of map and reduce slots available? How much is being utilized? What are the runtimes for all my steps? How is my provisioning done for VCO and my memory provisioning being done? Things like those. We have also added more of like how is my each and every single job working? So you can look at each and every single job status, either succeeded, failed, and if it fails, then what's the reason why it failed, who started it, things like this. We have added a lot of stuff to this particular dashboard. It was generated almost a month back. So futures. We want to be able to grade the clusters faster, so that we can classify them for faster resizing analysis. And that would bring more productivity into the environment, right? Because people will start taking care of their provisioning strategies in a much faster pace. There's a product called ITSI from Splunk, which basically it uses all the KPI-based knowledge and then provide you with ability to actually alert or write your own conditions in there. And we want to be able to use that to build an auto-analysis platform which will enable us to alert users on under-provisioning and at the same time over-provisioning too. We want to wake up people and say, okay, your CPU is only being utilized at 10%. It's not at 90%, it's only at 10%. And that's what we're trying to do, to better provision your system so that you're more cost conscious than before. And other than performance and the cost, we're also trying to bring in different variables in. The first thing which we're trying to look at is the amount of data which we are processing in each cluster, and be able to predict that, okay, this is the amount of cost which we are going to spend if you're running a cluster which has to go through 100 gigs of data. So that kind of analysis being done. And also the number of jobs or number of steps each particular function is taking place. Now, metrics correlation, analyzing steps. So we already have a small dashboard which does that, but what we're trying to do is basically take how all the steps are functioning and then put it upon the cluster's performance. So to be able to see all the cluster's performance or cluster steps performance based upon how my CPU and my generic NICS performance data is driven. We also have a dashboard which basically looks at how your steps is working, like success, failed, what are the properties for the step, runtime for the step. So in case a step is taking a longer time than what it ideally should, that's what we were trying to identify in the dashboard. But yeah, this is our future goal, to be able to overlay that information across the performance data. So when you see a step is being run at a longer time, then you can also look at your performance metrics and say, okay, why, or which particular service was the one which was using the most. And jobs impact on systems, we already do that now in the panel which we showed, but we are trying to improve it as much as we can. We are trying to integrate more components into it and show more data there itself, rather than forcing users to actually go and look at the raw log data. All right, so I'll give you,
Thank you, Sid. So my name is Praveen Rangnath. I run product marketing for cloud solutions at Splunk. I want to first start by commending Gary, Sid, and the FINRA team for what they've done. So you hear in these AWS keynotes that there's no trade-off between security and agility, right? So the FINRA team has proven that, right? They have their CloudTrail dashboards, they're monitoring user activity, they're monitoring all the security activity in their AWS account. But the story that you don't hear more is that there's also no trade-off between cost management and agility, right? A lot of people think if you want you to be agile in AWS, if you want to give your developers freedom, that it comes with the necessary cost and waste associated with that. But what Gary and team have proven is that's wrong. If you give visibility and awareness to your developers and users, you can accomplish all of the agility that you want out of AWS, right? What they've done is trim the waste. Developers still have the freedom to use AWS resources. They still have the same performance that they have on their clusters. So they've really shown that cost management and agility are not mutually exclusive in AWS, and I commend them for doing that. So now what I want to do is spend about 10 minutes talking about the underlying technology that's enabling the visibility that they have in AWS. So to start, just want to ask a question. How many folks in the audience here are familiar with Splunk and what Splunk does? Okay, most folks, good. How many are Splunk customers? Okay, many. Okay, fantastic. So let me go very quickly through the overview of what we do and just dive right into what we're doing into AWS and some new things that we have announced recently that'll be very useful for many of you. Okay, so I'll do this very quickly for the few of you that aren't familiar with Splunk. You know, what we're all about is taking your machine data and turning it into business value. So machine data is any data that's emitted from any of the systems that run your business. That can be a security device, it can be an application, it could be a web server. Everything emits a log data, a record, which contains a definitive record of what's going on in that system. Splunk collects all that data, irrespective of where it comes from. It can come from the cloud, it can come from on-prem, it can come from a virtualized environment. We take all of it in raw or unstructured format, so you don't have to do any parsing or processing before you send it to us. We can take it in small volumes. You know, if you're sending 1 gig a day, we can take 100 terabytes a day. We can take all of this data and make it available to you to search, visualize, analyze, and get insights out of. Now, what our customers use us for is a set of use cases across application delivery to troubleshoot code, to troubleshoot errors and exceptions in their applications. They use us for IT operations, for monitoring and making sure their infrastructure is running optimally and efficiently. They use us for security and compliance and fraud. We're actually a leading vendor in the Gartner Magic Quadrant for a SIM solution because all data now is security relevant. So companies use this data to get security insights. They use us for business analytics to learn how their business is operating, how their customers are interacting with their solution. They use us for IoT and the industrial data of things, and I'll talk about a little bit more about our integration with AWS IoT in just a few minutes. So this is what companies use Splunk for. We have about over 10,000 customers across 100 countries. Many of the world's most recognized companies use Splunk. You can see all the logos here. But what particularly stands out here is the overlap between the Splunk customer base and the AWS customer base. As evident right here, many of you are AWS customers, you're also Splunk customers, right? So not only FINRA, but Intuit, who is a huge AWS customer, all in on AWS, they announced 2 years ago that Splunk is a cornerstone technology for them for how they do operational and security monitoring. Adobe, Autodesk, NASA, all big AWS reference customers are also Splunk customers. So what do we offer the AWS ecosystem? We have a set of products where Splunk runs on AWS. We have a set of cloud services. Splunk Cloud is our full-featured cloud service platform that we offer on AWS. We launched Splunk Cloud 2 years ago, offering it just in the United States. We've since expanded internationally. It's now available in 10 AWS worldwide regions. We're also available in GovCloud for those of you that are US government customers with high security requirements. Our cloud service is the only one that comes with a 100% uptime SLA. So you guys that are familiar with Splunk, you know at the essence, when you need Splunk to be there, you need it to be there, right? If you have an error, if you have an outage, you need the ability to monitor and find out what's going on. So our solution, comes with 100% uptime SLA, and we achieve that by architecting across multiple AWS availability zones. We have dedicated instances for every customer, so it's not one large system where everybody's hitting against the same resources. Every customer has the same environment. We also use Splunk to monitor Splunk Cloud. So in that sense, you know, we drink our own champagne. We're using our own product to maintain the uptime of our service. We're also SOC 2 Type 2 certified, just to give the reassurance that we are a secure solution. SOC 2 Type 2 is when an auditor comes in, spends about 6 to 12 months on site, does a detailed analysis of our security practices, produces a 100-page paper, which we can make available to our customers, saying essentially this service is secure. We also have Splunk Lite. So for those of you that are startups or small IT teams, we have a full cloud service now that offers essentially the core elements of Splunk for what would be appropriate for a small IT team, which is some basic log search and monitoring, and that starts at just $90 a month. So this is new as of a few months ago, just a really low entry price point to start getting the value of Splunk, and you can pay for that by the month as well. We have software that runs on AWS, so Splunk Enterprise is essentially the software version of Splunk Cloud. So companies like Adobe Autodesk, what they're actually doing is just running Splunk Enterprise themselves on AWS. This is a bring your own license model. We also have Hunk, which extends Splunk analytics and visualization to the Hadoop world on EMR and S3. So if you've got a Hadoop environment, EMR and S3 on AWS, you can get visualization of that using Hug. Now, the most important thing, or the most new announcement, is our apps and integrations. We have our Splunk app for AWS that integrates with these AWS services you see here: CloudTrail, Config, Billing, S3, VPC Flow Logs, CloudWatch. When you listen to the keynote and the AWS sessions at the show, these services are being emphasized to a tremendous degree, and AWS is making a lot of advancements here with CloudTrail Inspector, with CloudWatch, config rules. AWS is really recognizing that visibility into the AWS environment is critical for any enterprise to truly adopt AWS and be successful in AWS. So this app that we offer is free. It's 100% free, no extra cost. We have a set of pre-built dashboards and reports which give you all the information you need to know about what's going on from these AWS services. So CloudTrail, for example, all your user activity in your account, who is performing an unauthorized action, who is trying to access a resource that they shouldn't have access to. We give you full instant visibility into that using our free application. Config is what are the changes in your resources, right? Is someone starting and stopping a resource? Is someone changing a security group on your resource? We give you instant visualizations and monitoring for that. Billing, you heard all about that from Gary, the ability to get real-time visibility into how much you're spending on AWS and correlate that to the usage of AWS so you can cut your spend without impacting the performance and results. VPC Flow Logs is a new service from AWS that lets you monitor your network flow traffic. So using that, you can see the network flow traffic, you can see the traffic going in and out of your IP addresses, and you can monitor that for operational as well as security issues. CloudWatch is a metrics and monitoring system that collects information from AWS, and that can be sucked into our app to get full visualizations. I'll show you some dashboards in a few minutes. We also had a set of new integrations with AWS. We have a new integration with Lambda. So for those of you that are not that familiar with Lambda, it's essentially a serverless event handler where you can essentially perform compute resources triggered based on an event. And it's becoming a very popular AWS service. So we have an integration with that, which is important for two reasons. One is you get visibility into that Lambda service itself. So if you're using Lambda in production, you want to know that it's performing as it's intended to. The second thing is a lot of AWS services natively write to Lambda. So you can now get visibility into what's going on in those services via connecting through Lambda. And I'll show you how that works in just a few seconds. Okay, so now you know what runs in AWS. Let me show you a quick few screenshots. Oh, actually, let me first tell you why this is important to you. So a couple of quotes here from analysts as well as AWS themselves. You can't protect what you can't see. That's from Gartner, right? Security monitoring will make or break a technology risk assessment program. That's IDC. Security requires visibility. That's AWS themselves in their intro to security session in all of their summits. Now, it's very clear. For you to have a secure AWS deployment, you need visibility. Analysts agree upon that. AWS agrees upon that. But you can extend this even further. You take that first quote, you can't protect what you can't see. What the FINRA team has shown us, you can't budget for what you can't see. Right? You can't operate what you can't see. You can't gain business analytics for what you can't see. You can't monitor what you can't see. Right? The role of visibility in an AWS deployment is absolutely paramount. And that is really where Splunk shines and fits in. So let me show you some of our dashboards. You'll first see a sample CloudTrail dashboard. So what we provide, this is all a pre-baked dashboard. It's actually, you don't even have to set it up for yourself. You just start sending your CloudTrail data to it. You can immediately see activity and information about all your users. How many users are on the system? What's being performed? What are any notable actions? What is some user activity that requires some further investigation? Here's our VPC flow dashboards, giving you information about your network traffic going in and out of your VPCs. So how does this network traffic look across a geographical map? Where is the network traffic coming from? Where is it going? What are some desktop destination and source addresses for this traffic? Right? You can get a very high-level view of what's going on, and so you can pinpoint, if there's any issues, you can then drill down and pinpoint to where there might be a problem. Here's a topology dashboard. This is actually something that's patent pending by Splunk right now. It's a single view at a glance of all of your AWS resources in your entire AWS environment, spanning across every region, every availability zone that you have deployed. So you can see here all the different instances that are running. You can see how they're connected to each other. You can see what's in a VPC, what's not in a VPC. You can see if there's a resource that should be in a VPC that's not in a VPC, that's inadvertently isolated. You can either delete that or you can bring that into your VPC. So this feature was actually shown in the Partner Summit to 5,000 people by the AWS VP that runs tooling and that runs the config and CloudTrail program. It's actually, I believe, the only way you get a single visual interface into all of your entire AWS environment across all regions, across all availability zones. Come see this in our booth, actually. We'll give a full demo of this app. It's really extremely powerful. You can interactively interact with this topology dashboard as well. It's very, very cool. Next, I talked a little about this integration with Lambda that's new. So we're the first partner of AWS to develop a blueprint for Lambda. And that's really important. What a blueprint really does is a set of templates which enables you to easily integrate a technology with Lambda. So from this, you can collect information about your Lambda service itself, as well as these services here that natively write to Lambda, things like Kinesis or DynamoDB. And I'll give you a use case of this. Coca-Cola is a large joint AWS and Splunk customer. So at a user conference, they were on a video saying that they have these freestyle machines, soda machines. So a freestyle machine is different from a regular soda machine that you don't just put money in and get out a Coke. You can actually pick what flavor you want and make your own flavor. You can say, I want orange, strawberry, vanilla Coke. And it'll mix it out, and it'll make you the exact flavor of what you want for Coke. And so they're building out more and more of these freestyle machines. They essentially make your own flavor machines. They're building this out across the country. And they're collecting data off each and every one of these machines to analyze what are the flavors that people like, and they find things like, at the University of Alabama, people really like to drink, strawberry vanilla, right? And they'll be able to target marketing based on the location of that freestyle device. So if there's a concert, a Taylor Swift concert, they can make a Taylor Swift mix, right? And advertise that to the people that are at that concert. So they want to collect this data. So they're a big Splunk and AWS customer. So the vision they have is to pull the data off of that freestyle machine, put it into Kinesis, where it then can be subscribed by any number of different AWS services, one of which is Lambda. So Lambda will then subscribe to that service, and then Splunk will pick up that information off of Lambda. So the workflow is basically the freestyle machine to Kinesis, to Lambda, and then to Splunk. And then they get real-time business analytics into how people are drinking Coca-Cola products. Right? What flavor concoctions are people making? How is that differing in different geographies around the country, in different age groups, in different venues? They get a completely different way to think about their business and how to serve their customers. So it's a very, very cool use case of how that data is being pulled into Splunk. Another thing that's new is our integration with AWS IoT. So this was a service that's announced today where essentially AWS is building a full IoT service where hardware manufacturers are bundling an SDK and a starter kit into these devices to make it really easy to collect data from these sensors, send it up to the AWS service. Right? So here's a use case and a dashboard of what we've built. If you guys remember from the keynote, they announced Splunk as the analytics platform for IoT, and we're in the press release as well about that. And this screenshot and demo is being shown in the AWS EBC in the IoT section. They're actually showing this integration we built. We've been doing this for months with them under NDA. So what this is basically is a bunch of sensors that's dropped in Sequoia National Forest. Right, so these sensors are all connected to the AWS IoT service. That's the example shown here. And what they're monitoring for is heat, right? And as well as a bunch of other metrics. So what you can tell is what is the risk of a forest fire emerging, right? If you have sensors placed throughout the forest monitoring the temperature, you then now can set up a real-time map, heat map, showing you what is the temperature change of these sensors. And if you start to notice a patch of sensors that's turning red, right, in real time, you can then dispatch the emergency personnel necessary to turn off to essentially fight that forest fire, right? So here's the importance of being able to analyze sensor data in real time, right? You don't want to have access to that data 6 to 12 hours later, right? You want to know immediately when are these sensors heating up, what is the indication of a forest fire, so you can go ahead and combat that. So this demo is being shown. We're the analytics platform for this service. It really opens up a new possibility for customers to get analytics from their IoT integration, from the AWS IoT service. So the end state of what we're offering is full visibility end-to-end into everything in your AWS environment. So if you walk the show floor here, you'll see a lot of point solutions saying, we'll give you visibility into this or visibility into that. The real vision that enterprises need is a full visibility into everything. Every single one of your AWS services, you need to know what's going on with them in real time. You need to be able to correlate what's going on with them in real time. And that's what Splunk offers. Right? Beyond that, the end goal is actually not end-to-end AWS visibility. It's end-to-end visibility across your entire environment, AWS and any on-prem environment. And that too is what Splunk offers with the hybrid platform. Right? Some of you are all in on AWS and 100% AWS. Some of you have a hybrid platform where you have some on-prem presence and some AWS presence. So what Splunk actually has is a hybrid platform that gives you both. Right? So in AWS, the holy grail is full visibility, but across your whole infrastructure, the holy grail is full visibility across AWS and all of your other environments as well. So last slide, your next step to AWS visibility, get started for free. We have free trials of Splunk Cloud on our website, a free trial of Splunk Lite on our website. The app is free, all these integrations are available at no cost. Come to our booth, grab this shirt, you bet your sweet sass. We make the best t-shirts in the business. I'm sure many of you have them already, please get them. We have a video. Our CEO was invited to be on stage at the keynote last year at reInvent. And so he gives a great talk outlining basically everything I said he outlines in much succinct way. So take a look at that as well. Last thing I'll leave you with is we're hosting a happy hour tonight. And many of you are Splunk customers, so you're invited. If you want to come to our happy hour, it's come here. We have a flyer that we can give you. You'll need the flyer to get in. It's at Tau Beach at 6 o'clock. It's a tremendous, very cool venue on the 4th floor of the Venetian. It's actually kind of a beach pool environment. So we have a lot of our major customers are going to be there. You can hear about how they're using our app. Gary will be there as well, so you can talk to him as well. So come up here, grab a flyer. We're here for questions as well, and that's a wrap. Thank you, guys.